Okay, we should be all good. Let me just check. Are we live? Yeah. Okay. Nice. Let me just turn that down, the volume. Okay, good. We're all good. Yeah. Okay, so we finished off with pointers, or starting with pointers last stream. So let's continue from there then. So last time we did, or we finished off. We finished off with references, and now we're going to do pointers. So let me go down here. So, intro to pointers. Cool. Pointers are one of C++'s historical boogeymen, and a place where many aspiring learners get stuck. There's nothing to be scared of. In fact, pointers behave pointers behave like L value references. Okay. Consider a normal variable like this. Char x, and it's unassigned. This is also true with references, where we have a char ref, and it now creates the alias of this. So because char, we use the char reference ampersand. Ref is now an alias for our char x. So this is also true with references. Assume it has the address 140. Ref is an L value to reference x, meaning it's the alias for x. Because ref acts as an alias for x, whenever we use ref, the program will go to the memory address of 140. to access the value again. Again, the compiler takes care of the addressing, so we don't need to think about it. Okay. The address of of operator and what other memory address used by memory? Okay. So yeah, like we learned last time, this will print the memory, the address of X, i.e., this X here. So although the memory addresses used by variables aren't exposed to us by default, we do have access to this info with the address of operator, which is the ampersand. So through the use of this. The address of X. So because we also use the and ampersand in our references, and we're also doing it in the y value, or sorry, the address value, we do need to make sure that we actually know what we're doing. Because we also use, when setting up a reference, and also to look up the address of a variable, we need to know that the ampersand means different things for different occasions. So when the ampersand is following a name type, it means it's a L value. When this signifies an L value, such as int ref. When the ampersand is used in a unary context in an expression, the address of the operator, is the address of operator, such as standard character output $x. So when it's used for the return type, it is the is an L value. When it's used in a unary context, is the address. And when the is used in a binary context in an expression, the is the bitwise and operator. Okay, that makes sense. So such as standard character output X and Y. The dereference operator. So getting the address of a variable isn't very useful by itself. So just getting the address of a variable by itself is not useful. The most useful thing we can do with an address is access the value of the stored address. The dereference operator, aka the star symbol, returns the given value at a given memory address as an L value. Now that doesn't, to be honest, that doesn't make sense to me, so I'm going to have to copy this out and see exactly what he's talking about. So we'll do include input output stream. We'll do our main return function. We'll do int x of 5. Then we'll do standard character output of x, which will just print 5. Then we'll print the address like this. This will print the memory address of variable x. So then we'll do standard character output, dereference operator, and then the address of x. So this will print the value at the memory address of variable x. And then, as always, we return 0. So let's have a look at this. So, okay, so in other words, this finds the address of x, and then through the dereference, through the operator, this then prints the value of whatever is stored in this address. Okay. So if we got the variable x of 5, and we're printing 5. Then we're printing the address. And then we're printing the address, and then we're finding what is in the address. Okay, that actually does make sense. Okay. Given a memory address, we can use so given the memory address, we can use the dereference operator, this here, to get the value of whatever is in the address of x, the L value of x. Yeah, so the address of gets the address, and then the dereference gets the actual value of the object in that address. Okay, so now we'll move on to actual pointers. So, a pointer is an object that holds a memory address as its value. So a pointer is an object that holds a memory address typically of another variable as its value. This therefore allows us to store the address of some other object to use later. So a pointer holds an object. So a pointer is an object that holds that holds a memory address as its value. So a pointer holds a memory address. A pointer holds a memory address as its value. Okay. A type that specifies a pointer. A type that specifies a pointer is called a pointer type, similar to a reference type syntax of that. So int, this is a normal int. Int and is a reference, L-value reference. This is an L-value reference to an int value. And then int pointer, this is a pointer int value, and a pointer is an object that holds the address of a value. An object that holds a memory address as its value. So in this case, it holds the memory address of an int value. Okay. So I want to practice this. Include preprocessor of the input-output stream header. Then in our integer main function, we have int x of 5, a normal variable. Then we have a reference of ref 2x. This is a reference to int x5. Then we have an int pointer this is a pointer to an int, because remember a pointer is an object that holds the memory address, the memory address of it as its value. A pointer holds a memory address as its value. I just want to keep getting it in my head and head. A pointer holds a memory address as its value. Save that. And then we'll to a reference type. Pointer initializations. Okay. So it is best practice to always initialize your pointers. So we have a normal integer variable, then we have a pointer uninitialized, then we have a pointer of where you have a pointer but it's uninitialized. Oh, null pointer, i.e. something that isn't isn't initialized or assigned. Then we have a int pointer 3, and we're initializing it with the address of x. So this pointer is initialized with the address of x. And remember, a pointer is a object that holds a memory address as its value. A pointer holds a memory address as its value. A pointer holds a memory address as its value. Okay, cool. A pointer holds a memory address as its value. Okay. Since pointers hold addresses, we can initialize or assign a value to a pointer. The value has to be an address. So typically pointers are used to hold the address of another variable, which we can get using the address of operator. So once we then have the pointer holding the address, we can holding the memory address as its value, we can then use the dereference operator to access the value of the memory address held in the pointer. Because remember, a pointer is an object that holds a memory address as its value, which is why we use the ampersand here. For example. So here we're going to do the preprocessor of include We're going to do input output stream. We're going to have a main return function. We're going to have a normal variable of 5. Then we're going to print 5. Then we're going to have a pointer type. Is that the correct wording? Yeah, pointer type, yeah. Just like a reference type. Int pointer and then ampersand x. Always remember that a pointer holds a memory address as its value and must always be initialized. So then we use the so once we have the pointer set up and the memory address as well, we can then use the to find the address, to find the value of the address. So we do standard character output, and we then do the dereference operator, and then we're going to print a new line. And then as always, return 0. So we are using the dereference operator. We're using the dereference operator to see the value held at this pointer's memory address, because we created the pointer type. We then gave it the variable name, and then we gave it the address of x. So if we print this, we should get 5. 5. And just to clear it up, I think if we did this, we would get the address. We would get 5, the address, and 5. Yeah, there we go. So we get the address there. So 5 on our machine is held there. This will print the address of the value of the memory address held by the pointer. Okay. Much like the type of reference has to match the type of object, the type of the pointer has to match the object being pointed to. Okay. So a pointer is an object that holds the memory address that holds a memory address as its value. Yeah. A pointer is a object that holds the memory address as its value. So pointer assignment. So we've initialized the pointer, and the pointer is an object that holds a memory address as its value. I know I'm repeating myself, but I just want to get it stuck in my head. A pointer is an object that holds a memory address as its value. Okay, cool. Nice. So pointers and assignment. We can use assignment with pointers in two different ways. We can use assignment with pointers in first being to change what the pointer is pointing to by assigning a new value. And then the second way is to change the value being pointed at by assigning the reference pointer a new value. So we can use the pointer we can change the pointer to point at something else, or we can use the pointer to change what's held in the memory address. Is that what he means? So to change what the pointer is pointing at. So let's do that then. So we'll do include input output stream. We'll do our return type integer for our main function. Then we'll do int x of 5. Then we'll do a pointer type of integer, pointer, and then that will be pointing at x. Remember that a pointer is an object that holds a memory address as its value. Oh, and we need an ampersand, my bad. So we do standard character output, and we're going to use the dereference to show what's in there. So this will print the value of the pointer memory address, and this will print the memory address. So then we have int y of 6, and then we're changing print to be the address of y. So here we are changing pointer, sorry, not print, the pointer to point at the memory address of y. So then if we did this, this would print the address of y, and then if we did this, the dereference, using the then pointer, I assume this would then print the value of the new memory address of pointer, aka y. So if we return 0 as always, and then if we cleared the terminal, so I assume we'd get an address here, we'd get 5 here, we are then changing pointer address, we then get a new address here, and then we get 6. That's what I'm thinking would happen. Yeah, cool. So you can see here our address changes the last two. Yeah. Okay, cool. So this prints a pointer. I know I'm keep repeating myself. A pointer is an object that holds a memory address as its value. Yes. Now let's look how we can use a pointer to change the value being pointed at. So that's number 1. And now let's do number 2. To change the value being pointed at. By assigning a dereference pointer by assigning dereference pointer to a new value. So let me clear that. Let me get rid of that. Our preprocessor of include. Now a header of input output stream. Then we have an integer of main. With our block. So I don't want to see what he prints because I want to work it out myself. So we have a normal variable of int x. Then we have a pointer value, not a reference value, a pointer type, sorry, which is pointing at x. This initializes the pointer with the address of x, and we always need an ampersand. So again, as always, let's print the address first. This will print the address. Then we'll print the value of what's in the address with the dereference pointer. This will use the dereference pointer to show us the value held at the address Why can you not just do... Oh, I'm going to stick with pointer for now. Then we use the dereference pointer and we make that equal to 6. So the pointer object at the address held by pointer is now assigned the value of 6 through the use of the dereference operator. Dereference pointer. So then if we print what the... No, I think... So yeah, then we want to show that the address hasn't actually changed, only the value. So we're printing the pointer. This will show the address, which shouldn't have changed. Then via the dereference pointer again, this should print the value, the new value held at the address, and then as always return 0. So I'm expecting the address here, this to be 5. We then changed via the dereference pointer to 6. So we change this to 6. Then this address, I think, should be the same as this address. And then this should show 6. So we should get address 5, same address 6. Let's have a look. Yeah, so we got the same address, we've just changed the value. Nice. That makes sense. This prints okay. So when we use a pointer without dereference, we are accessing the address held. Modifying, yeah, so the when using the address of operator, so the key takeaway is that when using the address of operator, This means we change the address. When using the dereference operator, this means we change the value held at the address. Cool. Okay, there's quite a lot. So I'm just going to take a quick break here, and then we can continue with pointers behave much like L values. And remember, an L value evaluates to an object, whereas an R value evaluates to a value. Okay, so I'll be back in a minute. I'll see you in a minute. Okay. Right. We still good on the audio? Yeah. Okay. All right. Nice. So let's continue then where we left off. Okay. So pointers behave like L value references. So we got a normal x variable with integer type. Then we have a reference type of ref referring to x. Then we have a pointer type pointing to the address of x. Then we're printing x. Maybe let's do it ourselves. So the preprocessor include for input output stream. Normal. We got a reference type pointing to x. And this should all be in our main function. That's why we're getting errors. Okay, then we have a pointer type, which is pointing to the address of x, because a pointer is an object that holds a memory address as its value. Then we will be printing x. Then we will print ref, which will be the address of x. Then we will be printing the, through the use of the dereference operator, the value of pointer. And at that point, we'll do a new line. This will, through the use of dereference pointer, print the value held at the address of x. Then we will make ref equal to 6, which is doable because you're referencing and reference can change. Use the reference to change x to 6, but we could have also done this, right? Yeah, yeah, but we're doing reference for now. So then again, we're going to print x. We're going to print our ref, i.e. the address. And we're going to print pointer. This will print the value of the This will print the new value held at the pointer address. And then, as I mentioned, we're now going to be changing it with pointer. So we use the reference pointer to change the value held at the address. And again, we're going to be printing x, and we're going to be printing the address. Yeah, and then we're going to be printing the new value. After changing the value held at the address via the point, and then, as always, return 0. So this should print 5, the address 5, 6, because remember our reference and our x variable is our aliases. So when you change ref, you change x. This will print the address, so it'll be the same. This, will this print 5 or 6? Well, if it works like a reference L value, I assume it'd be 6. And then we're changing it to 7. The thing is, it should be 6 because pointer is the address of x, and it's the value of whatever x is. Yeah, so this should print 7, address 7. And the only way to find out is to do it. So we got 5, 5, 5, then the address, and the value. That's why. That's why I was a bit messed up. 5, 5. No, sorry, my bad. This will, this is the value. So it's not the address, it's the value. Because it's an alias. Okay. And that should be that. And that should also be that. Be useful if I actually followed along. So you got 5, 5, 5, 6. Actually, to be honest, no. Yeah, no, leave it like that. I think is better. there are some differences between pointers and references worth noting. So, so we know that a reference creates an alias for a referent variable, and we know that a pointer is an object that holds the value um, that holds the value of the memory address. And we use the dereference pointer to either change the value held or to simply show it. So here we're using dereference to change, and here we're using dereference to show it. So the differences are references must be initialized. Pointers are not required to be, but should be. References are not objects. Pointers are. References, like we learned previously, cannot be reseated. Changed to reference something else. Whereas pointers can be. References must always be bound to an object. Pointers can point to nothing, which is a null pointer. References are safe outside of tangling references. Pointers are inherently dangerous. So the address of operator, which is the ampersand before a value, returns a pointer because it's the address. In other words, a given value returns. In other words, given variable int x and address of operator returns a pointer holding the address of x. So it's worth noting that the address of operator, no, not that, that's the dereference operator, or a pointer operator, doesn't actually return the address of its operand, rather it returns a pointer to the operand whose address is whose value is the address of the operand. In other words, int x, address of operator x, returns returns a pointer holding the address of x. This is because a pointer is an object that holds the value holds a memory address as its value. So we get rid of that. We do a preprocessor include as always. We do input output stream. We do type info to get the type. And then we do our return type integer main for our main function. We create a variable and initialize it as 4. Then we print standard character output type ID x and then name. Print the type of x, and then we do type ID address of x name, and then we do that. So print the type of and then as always we return 0. So we get an integer and then we get a PI, which I assume PI means pointer integer. Pointer to integer. So this prints which is an int and a pointer to an int. Okay, size of pointers and dangling pointers. So, size of pointers. The size of a pointer is dependent upon the architecture you use. Okay. So it just depends on the architecture as always. I'll just leave that there. And we can always come back to it. Okay, dangling pointers. Much like a dangling reference, a dangling pointer is a pointer that holds an address of an object that is no longer valid. Like, for example, if it's been destroyed. And like with a dangling reference, a dangling pointer will result or lead to undefined behavior because the object, i.e. the pointer, which is an object that holds a memory address as its value, has been destroyed and is no longer valid. Perhaps surprisingly, the standards say here's an example of a dangling pointer. So we got a reference type, we got a normal variable, we got an integer type variable, we got a reference pointer with the address of x. Then we have a standard character output, and using dereference operator to get the value of whatever is in the address, A5. Then we have a nested block creating a Y value. Then pointer, we use pointer to change the address. Then we print so we're using the reference. What was the exact name for it? Assigning a new value. And just a new reference. And then we're using the dereference to show a new one. But Y goes out of style, or not out of style, out of scope. And printer or pointer is now dangling because you've changed it, but it comes out of scope here. And then it comes out of scope, so you'd be expecting it to be 6. Let's have a look what it does on my machine. So you have int x of 5. We then have a pointer reference to the address of x. Then we have a nested value of int y, changing it to 6. Then we have pointer being changed to refer to the address of y. Then we print the value of pointer using the dereference operator. Then it goes out of style, out of scope. Then we will print again using the dereference operator. This leads to a dangling pointer and potentially undefined behavior, and then we return 0. So let's have a look what it does on my machine. 6, 6. Five, 5, 6. So okay. So conclusion: we know that a pointer, a reference, creates an alias for a variable, and a pointer is an object that holds a memory address as its value. So conclusion. So again, just to drill it in my head, a pointer is an object which is usually a variable that holds a memory address as its value. A pointer can be dereferenced using the dereference operator to a pointer can be reseated using the address of operator. Yeah. Pointers are more flexible than references and are more dangerous, but they're a lot more powerful. So, okay. What does this program print? Assume 32-bit. So we have a short value with a address of that. Then we have a short other value with the address of that. We're then creating a short pointer. We're creating a short pointer reference type, and with the address of value, so of this. So this will print the address. So this will print this. This will print 7. This will print this. This will print 7. And this will print a new line. Then we're changing using the dereference pointer. We're using dereference to we're using the dereference pointer to change the value of the memory address to 9 from 7. So this will print again the address, this will print the value, which will now be 9. This will print the address, which won't have changed. This will print the value, which will be 9. And then this will print, as always, a new line. Okay. Then we are using the pointer to change the address from here to the address of here, i.e. to this. So then when we print so this will then print the address of other value. This will then print 3. This will print the address. This will then print via the dereference operator. 3, and then this will print a new line. Then we have a size of pointer, which will be what's the size of a short? I don't know. But it will print the size of this. No, it won't. This will print the size of the address, and this will print the size of whatever short is. That's what I think. So again, yeah, you got the address, you got the value, you got the, you'd have to double check that what I'm saying is correct, but I believe what I've just said is correct when checking my answers. That prints the address, and then that prints via the dereference the value. Then the address will remain the same for here and here, but the values change to 9. Then your address changes to this, and the value changes to 3. Now this is the one. So we got 4 and 2. Okay, that's fine. I thought there was someone on my stream then, somehow, but there's not. It's just a website. It was just a website. Okay, cool. Yeah, that all makes sense. So what is wrong with this snippet of code? So we have an integer v1 initialized as 45. Then we have a reference pointer to the address of v1. Then we have v2 initialized as 78, and we're then assigning. We're using the dereference pointer to. We're using the dereference pointer to change. So this is what's wrong with it, because surely you don't need the dereference pointer, because the dereference pointer is either to get the value held at the memory address or change the value. But when you're changing the value, you oh yeah, you do that. So you're essentially changing the you're essentially changing the value, which was this, the value of v1, and changing it with the reference or the address of v2. So this and this is fine. I think it's this is the issue. Yeah, it doesn't compile. Let's examine the first and fourth lines contain variable. On the second line, the asterisk is a part of a pointer declaration. Not exactly, because you're not dereferencing, you're using the dereference operator, but you are changing the pointer value. So the line says assign the address of to pointer. That's fine. Oh no. Yeah, exactly. You should get rid of this. That makes sense. Okay. Null pointers next. I am just going to take a quick break and I'll be back and we'll see how much of null pointers we can cover. But as you can see, pointers are quite dense when it comes to C++, as we've only just done one lesson today. Okay, yeah, I'll be back in a minute. Okay, cool. Let's continue then. Right, null pointers. We'll probably keep going for another 20 minutes or so and then call it a day there, to be honest. Okay, so remember that we need to initialize our pointers. So something like this is not valid, but something like this, that should actually be something, that should be that. Something like this is not great, but it seems that's a null pointer, and you ideally want something like this. Yeah, because remember, our pointers are objects that hold a memory address as their value. Cool. Let me clear my terminal. Get rid of that. Okay. So we now know that. Are we going to finish this today? No, no chance. We now know that by using the dereference pointer, dereference operator, we can change the value held at a certain address. For example, include with our preprocessor, our header of input output stream. We then have a return of a main function. We then we create a variable of x and initialize it. Then we print the value of x. Nothing's complicated here. Then we create a pointer type that holds the address of x. Then we print out, so I'm going to print out the address, and then also, like he's doing, I'm also going to print out the value. And then as always, we return 0. So this should print 5, the address, and 5. Let's go. 5, the address, 5. Cool, nice. Via the dereference operator. Cool, that all makes sense. So, null pointers. Besides a memory address, there is one additional value a pointer can hold. So a null value is a special value that means means something has no value. When a pointer holds a null value, it means the pointer is not pointing to anything. So it's not pointing to, it doesn't have a memory address as its value, right? It's not pointing to a memory address. Hence why it is called a null pointer. So this, for example, is a null pointer. So for example, this. Yes, exactly. Visualize your pointers to be null pointers if you're not initializing them with the address of a valid object. Because we can use assignment, so because we can use assignment to change assignment, aka this, to change what the pointer is pointing at, the original null pointer can then be assigned to a actual memory address. So this one I want to do myself. So we'll do the preprocessor include. We'll do our input output stream. Then we'll do int main, and we'll do a null pointer. We'll do a reference type pointer null. This is a null pointer. So then we create a variable, a normal variable, and we use pointer, and then we use the assignment operator. So now pointer is pointing to the memory address of. So then if we were to print pointer address, this is the address. And then if we were to print using the dereference operator, this prints the value held at the new address. And then we can return 0. So clear my terminal. So this should print the address of whatever this is, and then 5. Yeah, cool. So we got the address and we got 5. This prints cool. Okay, so how long have we got? Quite a bit. So we're definitely not finishing it today, but we'll see how far we get along. Yeah, null pointer keyword. And of course, I don't want to rush through it. I want to actually make sure what I'm doing, I'm actually learning. Oakley dokley. Um, so represents a pointer literal. So the null pointer keyword represents a null pointer literal. Much like true and false, so we can use to explicitly initialize or assign. So for example, we can do include input output stream, our main function, and then we can do a pointer type, pointer, and we can set it to null pointer. We use null pointer keyword to make pointer a null pointer. Then we create a normal value of 5. Then we use a pointer reference, a pointer type again to do pointer to the address of value. The memory address of value. Because remember, a pointer is an object that holds a memory address as its value. Then we use pointer to be null pointer. So does that mean you're getting rid of the address? So we assign pointer to have the value of null pointer, meaning pointer to now becomes a null pointer. I assume that's what is happening. And then some func null pointer. So we can also assign, we can also pass null pointer as a param or argument. Return 0. Okay. Use a null pointer when you need a null pointer literal for initialization, assignment, or passing null. So the best practice is to use the null pointer keyword when you need a null pointer literal for initialization, assignment, or passing a null pointer to a function. Okay, I think we'll leave it there. So we left off at, dereferencing a null pointer. Dereferencing a null pointer results in undefined behavior. Lesson 12.8. Cool. So now we'll just go to our GitHub and change and save. And so we are on day 28. No, thanks. So day 28. What did we cover today? So we covered intro to pointers. And I know I'm repeating myself again and again, but a pointer is an object that holds a memory address as its value. We then use the dereference operator, which allows us to see the value held at a certain address. We then did pointers. We then did pointers initialization. And it's better to initialize your pointers, but you don't have to. If you don't, it will be a null pointer. Null pointer and assignment. And there are various ways to change it. You can either change the value or you can change the address. The value, changing the value is using the dereference operator and changing using the address of operator, which is this, and then changing the value is the dereference, which is this. Pointers behave much like L values. And remember, when you are doing a pointer, you must always use the address of operator when assigning it. The size of pointers, dangling pointers and their dangerous nature, and then conclusion, and then finally null pointers. And the null pointer keyword. Cool. Tutto bene. And today's date is the 28th of August. Cool. So that'll be that for today. We're going to be continuing next on null pointers and its undefined behavior. So I'll just do that. Yeah, so if you've been enjoying it as much as I have, let me know. Let me know what you think I could do differently, and other stuff you've seen me do that maybe I should have done. But yeah, as always, if you could leave a like, subscribe if you're new, um, and leave a comment as well, and all that good stuff. All right, I'll see you in the next one.